Okay, everybody, let's take a look at recapping the lessons today. What we're doing is really using logarithms, and we're changing the bases. So let's go back to this. The whole beauty of logarithms, like in this example, is they help us solve for x. You can't solve for x in this equation unless you just guess, or you learn logarithms, which is what we're learning. Okay, so we're solving logarithms with different bases. So let's start with the first example. Okay, evaluate log base 3. Now base 3 in your calculator, you got base 10, you got base 10 or base e, but not base 3. So you do this thing called the change of base formula. Okay, so you can take the log of 100 divided by log of 3, and you do that, go just log of 100 divided by log of 3, you actually get the answer. And that is the same thing as 3 to the x. So if I took 3 to that power, I should get 100, and I do. Now, we have fancy calculus. So if you don't have a fancy calculus, that's the only way you can do it. You have to do the log of 100 divided by log of 3 to get the answer. Now we have fancy calculus. So if you go into your math button and you go all the way to this log base, right? Oh, I got the wrong calculator. That's an old calculator. That one's not. This is not a fancy calculator, but this one is. So I'll show you. Okay, so then I go to math, log base right there. Okay, log base. And in this case, you can actually go log base 3 of 100. Pretty slick, huh? Get the same answer. So you don't have to do the change of base formula if you have a fancy calculator. So then, example 2, well, let's first of all rewrite it in log form. So we go log of base 5 of 80 equals x. So I can do the log of base change formula. I go log of 80 divided by log of 5, and we did that, log of 80 divided by log of 5, and I get an answer, boom. Or, oh, that's the wrong answer. Oh, I didn't divide, that's why. Log 80 divided by log 5, and yeah, okay, there's the answer. Or we have our fancy calculator. If you have this fancy button, fancy smancy calculator there, log base 5 of 80 with the same answer. Okay, depends. If you don't have a fancy calculator, you're gonna have to do it as the log base change way, or use a fancy calculator. Okay, now example 3 is a little bit harder. So because of the different bases, you can't use log base. You have to change them to the same base, which is base 10. So I took the log of both sides, which is log base 10, floats down the exponent. Okay? So after I floated down the exponent, I have to solve for x. Okay? So what I did to solve for x, so I'm trying to solve for x, I floated it down. When divide by log 3 on both sides, divide by log 3 on both sides, and I use my calculator, and I got a 1.262. 1.262 on my calculator. X, right, equals, now that's gone, and then to solve for x, just decimals, but minus 1x gives me a 0.26x equals 1, divided by 0.26, and I get about 3.818. So this is an example of how I had to make them the same base 10, okay? Okay, turn the page. All right, now, example 5. Now, if it's e to the x, I'm going to use natural log. I'm going to use e to the x because it's log base e, right? So I'm going to use natural log, right? And so I took the natural log of both sides. If I take the natural log of both sides, change it to log base e, natural log of 12 is just, on a calculator, 2.485. Use your calculator, natural log. And I use natural log because I know that ln of e is always equal to 1. So a really handy way to do this one is just take the natural log of both sides, brings down the x, and you get it. Okay, number 4, population of town grows exponentially, continuously. So I need e continuously at 1.5% interest. And we know the beginning population was 12,455, and the ending population was 15,000. Now, because it's continuous, I'm going to use my e formula. Okay, I use the PERT formula. P is the beginning amount. E is the number E, R is my interest rate or my rate, growth rate, times T, which is time. So I'm going to solve. So first thing I do is divide, and I got a 1.210444, okay, on both sides. And then I need to get the exponent down. So because it's E, I took the natural log of both sides, okay? So then I use the natural log of this number. I put it in my calculator, natural log of 1.024, put it in my calculator. I got about a 0.1859. And then by taking the natural log, I brought the exponent down, brought this down right in front, right there, and then natural log v. Now I know the natural log of v is 1, so I just crossed it out. Okay, then finally, I'm going to divide by 0.15, and I wind up about 12.4 years. Okay? All right, 5. A radioactive substance has a half-life, so I need a half-life of 12 hours. So I use my cycle of time, which is 12, so put the 12 there, okay? Starts with a sample of 400, and we let the experiment run until we only got 10 grams left, okay? So I set it up. I've got my 400s by beginning amount, half-life, cycle of time is every 12 hours, and so my ending amount is 10. So the first thing I did is divide by 400, divide by 400, divide by 400, and I got about a 0.25. And then I need to bring the exponent down. So I took the log of both sides. So I took the log of base 10. Brings it down, log of base 10. And then that brings down the exponent. Okay? Or I could change it to log base 1/2, which I thought was easier. I did it this way. And then the other way I did it was like, wait a minute, isn't this easier? Just take the log base 1/2 of 0.25 equals t over 12. And I multiplied by 12, and I got about 63.85 years. There's two ways to do it. You can see both ways. I like change it to log base 1/2. You could do it this way, divide, multiply, and you get it, okay? Anyway, that's what I have. If you have any questions, come see me.